We all know the world is pushing hard for renewable energy. Wind turbines, solar panels, they're popping up everywhere.
Absolutely. A huge global increase in clean power capacity.
And Egypt, they're right in the thick of it, aren't they? Showing some really impressive growth in their renewable sector.
They really are. This whole shift is, well, it's seen as critical for a sustainable energy future and obviously for tackling climate change. The pace is definitely picking up.
But here's the twist, the real curveball we're digging into today. As we rely more and more on wind and solar, how might climate change itself, the very thing we're trying to fix, how might it impact the future reliability, the potential of these energy sources?
Such a vital question. Because the environmental conditions, wind speeds, temperature, even cloud patterns, the very things that make wind and solar work.
Yeah.
Those are exactly the things climate change is projected to alter.
Yeah.
We really need to understand that sort of feedback loop.
Exactly. So for this deep dive, we're getting into a specific, pretty recent piece of research. It's a paper from 2024 looking precisely at this, focusing on Egypt.
Okay.
It examines the potential impacts of climate change on wind and solar energy potential there, projecting out to 2065. And it uses a high emission scenario, RCP 8.5.
Right, the business as usual one. It assumes we continue with high greenhouse gas emissions, leading to pretty significant future warming.
So it's one possible future path.
And a crucial one to assess, definitely, especially for infrastructure planning. You need to know the potential risks.
So our mission right now is to unpack this study. Let's find the key insights and figure out what these projections could mean for Egypt's renewable future and, well, maybe for strategic energy planning everywhere.
Sounds good. Let's explore what the paper found.
Okay, first things first. Why focus on Egypt? What's their energy situation like before we talk climate impacts? Where do renewables fit in now?
Well, Egypt is a really dynamic case study here. They're seeing huge growth in electricity demand. The study points out per capita use jumped significantly.
How much?
From about 977 kilowatt hours in 2000 up to 1,600 by 2019.
Wow, that's a massive increase in less than 2 decades. Demand is really soaring.
It is. And to keep pace, their total installed generation capacity has also grown like crazy, almost doubled, from just over 27 gigawatts in 2010 to nearly 60 by 2020.
Okay, so they're building out infrastructure fast. How much of that new capacity is wind and solar?
Well, the share of solar and wind in their total installed capacity actually doubled between 2010 and 2020. But what's really striking is the recent acceleration.
Go ahead.
Between 2015 and 2020, the installed capacity for solar and wind saw an average annual growth rate of, get this, 37.6%.
Whoa, nearly 40% average growth each year for 5 years straight. That's incredibly rapid expansion for wind and solar.
It really is. Meanwhile, hydropower, which has historically been important, its share actually decreased over that time.
Why is that? Did they decommission hydro?
No, not really. It's just that its installed capacity stayed pretty much the same, while everything else, especially wind and solar, grew so fast around it, so its relative share went down.
Ah, okay. Makes sense.
And the paper makes a key point here. While there's been research on Egypt's current renewable potential, most of it doesn't really factor in how future climate change might change that potential down the line.
Right. And that's the gap this 2024 paper is trying to fill, looking decades ahead under that specific climate scenario. Okay, so before we dive into the Egypt-specific findings, the paper gives a quick overview, right? How can climate change generally affect wind and solar?
Yeah, it lays out the basic mechanisms. For wind energy, the absolute biggest factor is wind speed. Power output is proportional to the cube of wind speed.
The cube, wow.
Yeah, so even a relatively small change in average wind speed can mean a much, much larger change in the potential power you can generate.
Okay, that's huge. Anything else for wind?
Air density also plays a role, and that's affected by temperature, though it's less critical than speed. And then there are extreme weather events.
Like storms.
Exactly. Things which might get more frequent or intense with climate change, and they can force turbines to shut down for safety. Too much wind is also a problem.
Right. Okay, what about solar? Solar panels, PV.
For solar PV, the main climate sensitivity they focus on is temperature. As the panel itself gets hotter, its efficiency decreases.
Why does that happen? Just gets too hot to work well.
Sort of. Think of it like this. Hotter panels just aren't quite as good at converting sunlight into electricity. Technically, the electrical current might slightly increase, but the voltage, the electrical push, drops more significantly.
Ah, so the net effect is less total power output.
Precisely. Hotter panels are just a bit less effective.
Got it. And I think you mentioned the paper briefly touches on hydropower vulnerability too.
It does, yeah. Mentions that changes in rainfall, evaporation, things like that, can definitely affect water flows for hydro. But the study's real focus, its core analysis, is squarely on wind and solar potential in Egypt.
Okay, good to clarify. So how did the researchers actually do this? What was their method?
They used a GIS-based approach, Geographic Information Systems. So essentially layering different data sets onto maps of Egypt.
What kind of data?
For the future climate projections, things like wind speed, air temperature, air pressure, they use data from a project called Cordex.
Cordex.
Yeah, it provides climate change scenarios that are sort of downscaled to specific regions. They looked at projections for the period 2050-2080, using 2065 as kind of a central point under that RCP 8.5 scenario. And they compared that future picture to a historical baseline, 1970-2005.
Okay, and what about the solar data?
For that, they used global solar irradiation data.
Mm-hmm.
Sources like the Global Solar Atlas provide that information.
Right.
Then they basically applied formulas. One to calculate the available wind power based on air density and that projected wind speed.
Okay.
And another formula for the PV module power output based on the projected temperature and the irradiation levels.
So they took the climate model outputs and essentially translated them into maps of energy potential.
Got it.
All right, let's get to the results. What did they find? What's the projected impact on wind power potential in Egypt by 2065 in this scenario?
Well, first, looking at the baseline, the current situation. The areas with the highest wind potential in Egypt, typically where wind speeds are over 4 meters per second.
Which is considered pretty good, right?
Yeah, that's often a threshold used for viability. Those areas are mainly along the Suez Gulf, the Red Sea coast, and also the northwestern coast.
Okay, makes sense. Coastal areas, the Gulf, usually windy spots. How does climate change mess with this picture, according to the study?
Well, here's the first interesting finding. The study projects only a relatively marginal difference in the overall annual average wind speed across the whole country by 2065.
Oh, okay. So not a huge change overall.
Not in the countrywide average, no.
Yeah.
But, and this is the crucial part for wind, the impacts show significant regional variation. It's not the same everywhere.
Okay. Tell me about that. Where does it change and maybe why?
The northern coastal zone, that northwestern area we mentioned, it's actually expected to see declining wind speeds.
Declining. Why?
The paper suggests a possible reason linked to rising global temperatures. The idea is that warming might reduce the natural temperature difference between the poles and the tropics.
Okay.
And that temperature difference is a major driver of the large-scale atmospheric circulation that creates mid-latitude winds. So if the whole planet warms, that contrast might lessen.
Leading to slightly weaker winds in places like northern Egypt?
That's the hypothesis put forward in the paper, yes.
Mm-hmm.
A really interesting large-scale climate connection potentially affecting local wind resources.
Fascinating. Okay, so decline in the north? What about elsewhere?
Conversely, other parts of Egypt, places like the Suez Gulf again, the Nile Valley, and some desert areas like Sharq el-Inwinat and the southern eastern desert, they're expected to see increasing wind speed.
Oh, okay, so increases there. That sounds good.
Well, yes and no. Often these areas where speeds increase are starting from a much lower baseline wind speed. So even with an increase, their potential often stays relatively low, maybe still below that 4 meters per second threshold for high potential.
Got it. So wind speeds might go up where the potential wasn't great to begin with, but potentially decrease in some areas where the potential is currently high.
That seems to be the pattern emerging, yes.
Yeah.
Overall, the relative change in wind speed is projected within about plus or minus 5%.
Okay, 5% change in speed, but what you said power relates to the cube of the speed.
Exactly, you remembered. That cubed relationship is key. Because of that, when you translate the uncanny 5% speed change into energy potential,
It gets magnified.
massively magnified. The projected change in wind energy potential is estimated to range much more widely, anywhere from a 12% increase to a 12% decrease by 2065 compared to the baseline.
Wow, a potential swing of 24 percentage points in energy potential. That's huge. And what about those specific high potential areas you mentioned, like the northwest coast and Suez Gulf?
This is probably the most critical takeaway for wind in Egypt from this study. Those areas currently identified as having high potential, specifically the northwestern coastal zone, where potential is over 40 watts per square meter.
That's the measure of power density, right?
Yes. That area is expected to see a significant decrease in potential, as much as 38.1%.
A 38% decrease in potential in a prime wind zone? Ouch.
Yeah. And the Suez Gulf, another really prime wind area, even higher potential, above 50 watts per square meter. It's projected to see a smaller decrease, but still a decrease, around 2.5%.
Okay, this is where it gets really interesting and maybe concerning for planning. The areas that look best for wind power now, where you'd likely focus investment, are projected to see their potential decline, especially significantly in the Northwest. That seems like a major planning headache.
It really is. The authors specifically highlight this. These mixed impacts, especially the projected decreases in those existing high potential northern areas, suggest there might be limited scope for big wind power expansion in those specific regions under this future climate scenario.
Right.
Which, could directly challenge current expansion plans and might mean they need to look more towards other energy sources or perhaps different locations or maybe even different technologies in those areas.
Okay. So for wind, it's a picture of quite varied, regionally specific, and potentially challenging impacts, especially where the resource is currently strongest. How does the study paint the picture for solar power potential? Is it a similar story of complex regional changes?
For solar PV, it's actually, a bit different. The primary driver of change in this study is that projected increase in temperature affecting the panel efficiency.
Right, hotter panels, less efficient.
Exactly. So under the baseline period, the study estimates the output of a typical PV module averages around 310 watts.
Okay, 310 watts baseline. And the warming projection by 2065.
Under that RCP 8.5 scenario, they project average annual temperatures across Egypt increasing by somewhere between 2.3 and 3.4 degrees Celsius, depending on the region. The countrywide average warming is about 3 degrees Celsius.
That's pretty substantial warming.
It is. And as we discussed, hotter panels mean lower efficiency. So logically, this temperature increase is expected to reduce the power output of solar panels.
Okay, so what's the bottom line then? How much does solar power potential decrease across Egypt?
The projected average power output for these PV modules is expected to decline slightly, down to about 308 watts by 2065.
310 down to 308. That sounds, much smaller than the potential 12% swings we just talked about for wind potential.
It is significantly smaller, yes. If we quantify the relative change, the study estimates the decrease in PV power output will range between about 0.9% and 1.5%.
Okay.
With the average decrease across the whole country being about 1.3%.
Right, so a much smaller hit, around 1.3% on average, and it seems more consistently a decrease, unlike the up and down picture for wind.
Are there regional differences for solar too, though?
Yes, there are, but maybe less dramatic than for wind. The study projects the highest percentage reduction in PV module output will actually occur in Upper Egypt in the south.
Oh, why then?
Because that region is projected to see the highest absolute temperature increases. Even though Upper Egypt currently gets the most intense sunshine, the highest solar irradiation.
The place that gets the most sun takes the biggest hit to its solar efficiency because it also gets the hottest. That seems a bit counterintuitive.
It does, but it highlights the nuance, right? What's fascinating is the implication of this. Because the temperature increase is expected to be less severe in the northern parts of Egypt. Those northern areas, while getting slightly less intense sun than the south, might actually end up having relatively higher future solar potential compared to Upper Egypt by 2065.
So wait, not because the sun gets stronger in the north?
Yeah. But because the efficiency penalty from rising temperatures is less severe there compared to the much hotter south.
Exactly. It's about how the change in temperature interacts with the baseline conditions. The north might fare relatively better for solar in the future, even though the south starts out sunnier, because the temperature impact is less damaging.
Wow, okay. That regional nuance is important too. So this brings us to a really key comparison then. Based on these contrasting findings, how do wind and solar stack up against each other in terms of their overall vulnerability to climate change impacts in Egypt, according to the study?
The study offers a pretty clear conclusion on this point. Solar energy potential is expected to be relatively less vulnerable to the projected impacts of climate change compared to wind energy potential, looking out to 2065 under this scenario.
Okay, let's just put those main numbers side by side again for clarity.
Sure. For wind energy potential, the projected change was in that wide range, up to 112%. And importantly, it included those significant regional variations with potential decreases of up to 38% in prime existing wind zones in the north.
Right. Big swings, regional problems, and solar.
For solar PV power, the projected impact was much smaller and more consistent. An average decrease of only about 1.3% across the country, driven primarily by that temperature efficiency link.
Okay. And the fundamental reason for this difference in vulnerability really comes back to those core mechanisms, right?
Exactly. Wind power output is just incredibly sensitive to changes in wind speed because of that cubed relationship. A small change in the input gives a big change in the output.
Whereas solar PV.
Solar PV efficiency is affected by temperature, yes, but the sensitivity just isn't as pronounced. The relationship isn't as exponential, let's say.
Got it. So thinking bigger picture now, what are the major implications of all this for, strategic planning and energy policy, particularly in Egypt?
Well, if you connect these findings back to how a country like Egypt plans its future energy mix, the message from this study is pretty stark. You can't just look at today's renewable potential maps and assume they'll hold true for decades.
Right.
You absolutely have to factor in how climate change might alter that potential, and crucially, that it alters it differently for different technologies and in different places.
So the varied impacts they found when facing these complex, regionally specific challenges, especially in key areas, while solar sees a more manageable, consistent, though still negative impact that has to inform decisions.
Directly. It should absolutely inform policy decisions about where to invest, maybe how much to lean on one technology versus another in certain regions.
Does the paper actually offer a specific suggestion based on this comparison between wind and solar vulnerability?
It does, yes. The authors explicitly suggest that future renewable energy policy in Egypt should potentially place a greater focus on solar energy compared to wind energy.
Really? Based on?
Based specifically on their finding that solar potential is projected to be less negatively affected by climate change than wind potential in Egypt, under this specific high-emissions scenario they modeled.
Huh. That's a pretty direct recommendation suggesting maybe a strategic tilt towards solar might be warranted based purely on these climate resilience projections.
It is, and it really just underscores the immense value of doing this kind of forward-looking climate impact assessment before you make massive long-term investments in energy infrastructure. You need to know what the future climate might do to your assets.
Okay, let's try and summarize the core takeaway here for you, the listener. Based on this particular 2024 research looking at Egypt out to 2065 under a high emissions climate scenario, the main message is that wind energy potential seems to face potentially more significant and definitely more varied impacts from climate change compared to solar PV power.
That's right. While solar is expected to see a decrease in efficiency due to rising temperatures, it looks like a smaller, more consistent impact across different regions, maybe around 1.3% on average.
Whereas wind energy potential sees a much wider possible range of change, that 12% figure. And crucially, some of the currently best areas for wind, especially in northern Egypt, are projected to experience quite notable declines in their potential.
And understanding these projected differences, how climate change might hit different renewables in different places in different ways, is just absolutely essential. It's about making informed choices now to build a renewable energy system that's not just big, but also resilient and reliable for the long haul, in the face of a changing climate.
Indeed, and it really leaves us with a provocative thought to chew on, doesn't it? Given these projections show climate change playing favorites, so to speak, impacting wind and solar differently, affecting various regions differently, like potentially reducing wind where it's best now, while maybe making solar relatively more attractive in other areas due to those temperature effects. What kind of really flexible, maybe highly tailored, regionally specific renewable energy strategies will countries like Egypt and probably many others need to develop? How do we ensure long-term energy security in a warming world when the resources themselves are shifting? It suggests maybe it's not just about which renewable, but the precise combination and location in a whole new way.